reaction due to IQ is equal to, what is effect of armature reaction due to ID? This is opposing phi f. See, ID will produce corresponding field flux, and this we know that flux is proportional to current, field current. So, when ID is 0, I is 0, phi is 0, when I is maximum, phi is maximum. So, this is opposing, that is demagnetizing. Due to this ID, it will be demagnetizing plus due to this is lagging this. So, we have seen in our previous lecture, if it is lagging 90 degree, with the help of waveform also we have discussed, if it is lagging by 90 degree, so what will be the effect? It will oppose in leading half and help in trailing half, that is cross magnetizing, known as cross magnetizing. So, we may write cross magnetizing. So, let us take second case, case B, leading, not lagging. This time let us take, if internal power factor is, angle is between 0 and 90 degree, leading. So, corresponding will be, this time current is leading, this is psi. So, once it is leading, so again as per Blundel's two reaction theory, we can resolve IA into two components, one along D axis ID and one along Q axis IQ. Hence, the effect of armature reaction due to IA in this case will be equal to effect of armature reaction due to ID and effect of armature reaction due to IQ. So, first one is helping, see here, ID is helping phi f, and IF, direction of IF will be same as phi f. Do not get confused with a space phasor diagram, as IA, if this is IA, so direction of flux will be 90 degree space apart. I am talking about this time phasor diagram. When I is 0, phi will be 0. Whenever I is maximum, phi is maximum. Whenever I is there, phi is there. Whenever I is not there, phi is not there. Means whenever I is crossing 0, phi will cross 0. So, do not get confused between time phasor diagram and a space phasor diagram. If you will talk about a space, so if this is the axis of I, current direction of flow of I, so obviously curling of fingers, if we are going to hold with right hand, so curling of fingers will give the direction of flux in a space. But once we are talking about time phasor diagram, so whenever I is maximum, phi is maximum. I is in phase with phi in time phasor diagram, right. So, what will be its effect? It is helping. So, that is known as magnetizing, purely magnetizing. And what is its effect? Again cross magnetizing. So, in this case effect is magnetizing and cross magnetizing, mixture of these two effects will be there. Now, let us discuss one modification made by Doherty and Nickel. So, write down Doherty and Nickel's modification. Doherty and Nickel's modification. What is this? Doherty and Nickel modified to analyze the effect of armature reaction alternately. They said that the effect of armature reaction can be analyzed by assuming two hypothetical reactances X AD and X AQ. What are these two? Two hypothetical reactances where XAD is a hypothetical reactance corresponding to the effect of armature reaction along the axis, and XAQ is a hypothetical reactance corresponding to the effect of armature reaction along Q axis. So, how we are going to analyze these two reactances? We know that if this is a stator, so let us consider salient pole structure. So, air gap is not uniform in this case, salient pole structure, while in case of cylindrical structure it is uniform. So, once air gap is not uniform, so the armature fluxes, we are talking about armature reaction, that is effect of armature flux on main field flux. So, those armature fluxes produced by armature currents will get more ease in crossing the air gap here because of the minimum air gap length. In other words, flux linkage will be more where air gap is minimum along d axis, where air gap is minimum along d axis, whereas along q axis, see, the air gap is maximum. So, the effective corresponding reactance here will be lesser or more? More. How? The air gap is minimum, it means reluctance is minimum. Once reluctance is minimum, it means more and more flux lines are passing. It means flux linkage is maximum. Wherever air gap is minimum, reluctance is minimum, so flux linkage is maximum. Once flux linkage is maximum, corresponding inductance is maximum, hence inductive reactance is maximum along d axis. Similarly, along q axis, air gap is maximum, hence reluctance is maximum, hence flux lines passing through this is minimum, that is flux linkage is minimum, corresponding inductance is minimum, hence inductive reactance is minimum. So, this XAD is greater than XAQ, while in case of cylindrical air gap is uniform. So, XAD XAQ will be equal as air gap is uniform. We have one more reactance, that is known as leakage reactance. What is that? What is leakage reactance? Due to leakage flux. Where fluxes are leakage? What is leakage flux? Leakage fluxes are those fluxes which do not contribute to the useful flux, means which, okay, for example, let us take an example. Let us take one slot here on a stator. We have one slot and one conductor. Let us dot is there. Polarity is like this. If rotation is this, then polarity will be this, right? Clockwise. Whatever the polarity, any polarity, just take dot. So, corresponding dot is there, flux lines will be distributed like this. This the marked directions, marked directions, marked directions, marked directions. We know, right? Density will decrease, but the direction will like this. So, see, some flux lines are crossing the air gap, linking the rotor, whereas some flux lines are confined to the slot itself. Some flux lines are confined, will be confined to the teeth itself. This will not cross the air gap. So, these fluxes are known as leakage flux. So, where leakage fluxes will be there? Slots, teeth overhang will also be there. In overhang, that is not active length, but once flux is current is flowing, armature current is flowing, so corresponding fluxes will be there. So all those fluxes which do not contribute to the useful flux, that is, while considering the effect of armature flux on main field flux, all those fluxes which have not been considered are leakage flux. So if these fluxes are not affecting the main field flux, that is leakage flux, it means we have not considered their effect while discussing armature reaction. We know that armature reaction is a reaction of armature flux on main field flux, and because of that the main field flux is disturbed, changed, either decreased or increased. So corresponding EMF induced will be increased or decreased in the armature winding, stator armature winding. So in order to consider the effect of these leakage fluxes which have not yet been considered in armature reaction, see these fluxes, leakage fluxes will also, let us represent leakage flux by phi L, will also induce EMF in the armature winding. How? The current flowing in the armature conductor is alternating in nature. So hence whether flux is leakage or linkage flux, linking to the rotor, both will be having same nature, alternating in nature. Because of that EMF will be induced minus m n number of turns d phi L by